joining the third session of GenAI Enablement series. I know it's hard to come on a Sunday. That's the same for most of us. But I think based on the momentum and what we see in the tech industry and how the trend is happening and what's a leap, we should definitely get plugged us into some of these AI enablements and how do we get hands-on with the GenAI development tool. So it's essential, and that's why Team Real wanted to actually have one of this series to actually have it and share with the team live, and also have it on demand for the future purposes as well. And if you have missed the last two sessions, first session we were talking about the trends. So what's happening, what are the tools available, how this actually makes our life easiest on various aspects. It could be in your tech or daily job or your daily life, whatever it may be. So how it actually helps you accelerate anything that you do. And we are also talking about what happens to the job. So there was a good debate happened with Dinesh and Naveen. And we also talked about different models which are available, basically the large language models that we talked about. So what are the models available and what are their capabilities and how they even hallucinate. And one other thing was, Naveen pointed out, so you should be the director always. So use any GenAI applications as your PA. So you be the director at any point in time, whether you write the code or you write reasoning or you get anything from the GenAI apps. That is the first session. And second session, we were mainly into prompting. So it's a core skill for interacting with the machine learning models, LLMs. So we were talking about prompt engineering, and we had also played fun games with Party Rock and Gandalf Lakera. I hope some of you tried even when you went back home, and it was a fun challenge. And also we were able to interact with the Gemini model. So even myself, Silva, and few others were talking in the night around 11, where Gemini also released a recent model, which is capable of 2.5 million parameters. Yes. So it can handle tokens, not the parameters, the tokens. And how it was actually on the ADER leaderboard, etc., etc. I think a lot of things are happening, and that was one of the hands-on session was happening in the session 2 as well. And today we are going to have a new, I would say, instructor, trainer, or expert, or researcher, enthusiast, we can call anyway. So Aman Sharma, we work together. We were working together long back on different technologies, and he was one of my go-to person for anything which goes into competitive programming or reasoning, etc. And he was actually studying in IIT, doing his master's, and then he went into Samsung R&D. And then he was also doing some of his research on GenAI areas. So he has a lot of passion into training since back in 2011. He has done several trainings for students, corporates, different interest industries on different technologies. So definitely we are glad to have Aman here today because he comes up with a lot of experience, passion into technology, and recently into GenAI research as well. So happy to have Aman talk about RAG, and I hope it will be very good insight for all of you, and happy to interact with Aman today. So make use of this time. Yep. Thanks so much, Aman, for joining us. Really a good time to have you here for next 2 hours, 2.5 hours. Looking forward to it.
Yeah, thanks, Ram, for the wonderful introduction. And really thankful to you for the invitation. So I thought like it would be a great opportunity to talk about RAG. So first of all, good morning, everyone. And I would like to thank each and everyone personally for joining, because the number is so less. But we are going to talk about something very exciting. today, like how can we make AI systems like ChatGPT or like Perplexity even more smarter and more reliable by connecting them to the right external knowledge. And this concept is called as augmented generation. And by the end of this session, we feel that I feel that we should be able to see how it works and why it's important and how it's shaping the future of AI. So I'll just share my slides now. So it says sharing has not been turned on.
You should be now. Yep. Okay, can you check them on once?
I'm checking now.
Yep. Okay.
For some reason, it is just showing this Google Chrome unknown desktop one. 1 minute. Okay, we'll do it.
Okay, Someone, are you joining via browser or the desktop app?
So, should I join via browser?
Uh, yeah, it should be fine. Both of them should work fine, but maybe internal permission issues.
I'm using Zoom after a long time. I used to use this Google Meet.
Oh, okay.
Do you see any share from my side? Not yet.
Not yet. Not yet.
Let me share the system settings.
Yeah, if you want to share the decks to me, I can help you present as well.
Okay, okay.
Yeah.
I think for sharing, we need to grant permission and we need to rejoin the session to make it working. That's how I think Zoom works.
Okay, I'll be. Am I audible?
Yes. Yep.
Is it visible now?
There you go. Yes. Yep.
Okay, that's great. So today's session is augmented generation, smarter AI with RAG and LLMs. So we'll start now. We have how many? We have 20 plus participants. So we'll start the day, or not of the day, of the month. So IPL fever is there. And how can we not start with IPL? So Ram, did you get to see yesterday's match?
Not yesterday's, but I was following the earlier matches.
Okay. But you know that yesterday was CSK's match.
Yes. Yeah. The first match was CSK. Yeah.
Okay. So now that's the perfect, like for me, for you not to watch the match. Now, if I ask you how many runs did Dhoni score yesterday? Will you be able to answer?
No, without knowing the data, no.
Like you should not be opening Crick Info right now.
Okay, let me guess. Maybe 45?
45, okay. And who won the match?
CSK?
That is very optimistic for you. Then I can ask like many questions, like which batsman scored what runs and how many. Like if you would have watched the match, I would have asked different questions, like what was the score when Akshar Patel got out, and so on.
Okay. Now we have people who are actually hardcore cricket fans and Dhoni fans. So definitely people will be answering that. So let's pick someone else.
No, it's okay. It's okay. I think I wanted someone like you only who has seen the match. Okay. So these questions you're not able to answer. Now I'll give you this. If I ask you like how many runs did Dhoni score?
So it's 30.
Okay. And what was the score when Akshar Patel got out?
That is that bowling.
He bats from Delhi Capitals.
Okay. So Akshar Patel, it is 90 of 3.
Correct. Okay. So initially when I asked Ram what was the score and how many runs did Dhoni score and what was the score when Akshar Patel got out, what went wrong? Like, so communication wise, my question was clear to Ram, and Ram can also communicate very well. If we talk about cricket knowledge, we have played cricket together. I know that Ram has superb knowledge in cricket. And if we talk about comprehending the scorecard, that also Ram can do, because we just now saw that he was able to refer to the scorecard and he was able to answer the questions. So what was missing when I first asked the question? So the thing that was missing was real-time match info data or actual scorecard data he was not having. Same is the case with LLMs. So if we draw an analogy of LLMs with a cricket match, this is exactly how LLMs work. So LLMs have been trained on some prior data and which may be outdated over a year or over more years, depending on the model that we are using. But they have capability of understanding language, understanding data, and they have capability of understanding patterns. But what is missing at times is current or relevant data. So this is where this RAG comes in, retrieval augmented generation. And the name itself is so clear that we should not have this session at all, because some of the names are so clear, like what does a boiler do? It boils. What does a sensor do? It sense. Similarly, retrieval augmented generation is such an apt name for this. So what it does is it retrieves the relevant information that is needed by the LLM to answer your query. And then it augments it with the query. So let's say I'm asking what was the score of Dhoni. Along with that, if I this scorecard and let the LLM decide. And based on that query plus relevant information, we let the LLM generate the model. So this is what is retrieval augmented generation. And it gives power to LLMs in many ways, like some of the applications which are hardcore dependent on real-time info. LLMs can't find use case there. But when we bring in something called RAG and it is able to retrieve the relevant data or the real-time data, then it makes much more sense. So there is a very popular quote by Socrates. He says that as for me, all I know is I know nothing. So I'm expecting that you know nothing about RAG, and this is how I have shaped the session also, so that if someone knows basic about RAG, they should feel enriched. If someone don't know anything about RAG, then also they should be able to understand. If someone is an expert, then they should take the second half of the session. Okay. So what now if someone asks you like, Ungal ke RAG teri ma, do you know RAG? So now I have taught you this much that you should be comfortable in answering yeah in a RAG therium. Okay. But the problem is that's all you know. Okay, so we don't want to leave you at this state. An ideal state could be like, we can take you like, you know, everything about RAG, which is also not possible because RAG is such an evolving topic. It's very hot in the market of research. A lot of things are happening. So everything is not there on the boilerplate and we don't know also. So we want, after the session, what we want is that you should be in a confident state about RAG. And if you feel like developing some applications using RAG, you should be comfortable to start with. So that's the expectation session. Brief outline of the talk is like, we'll start with embeddings, how text is represented when it is understood by machine learning models. And then we'll see uh, the embeddings, how it is stored in vector databases. And after that, the game of RAG will start. And RAG in general, nowadays is divided into three parts. One is naive RAG. Naive RAG is the one that I talked about. Simple, like get the relevant chunks, augment it and generate the data. That is naive RAG. But then there are multiple things. So naive RAG cannot be deployed into production because of many factors. And from there on, the next version that comes when people started deploying RAG in production is the advanced RAG, where they try to perfect the imperfections in the naive RAG. And the latest in the market is Agentic RAG, in which you have multiple agents and you decide which agent you should use, or if you want to get the real-time information of, let's say, stock market, then what API you should use. So that self-thought and that self-awareness of using which API, that is hot in the market, and people are trying to get hands on this agentic RAG. And finally, we'll conclude. So this is a very small talk. It won't take much time. So first thing that comes is embeddings. So why I'm talking about embeddings is, if you take text, because most of the LLM itself stands for large language models, so they deal with language. So how should we represent language in a way that a machine can understand? Because machine understands numbers. But I'm not able to see my screen. I'll just minimize this. It's fine. So machine understands numbers. So how should we represent text into numbers so that the machine can understand? Okay. And these cannot be some random numbers. It has to have some meaning. So embeddings are numerical representations of data or text, we can say for now. And what they capture is meaning and relationship in lower dimensional space. So for example, if vector embedding example, there are these words: king, man, woman, apple, banana, orange. So embeddings, what it does is it will convert this text into some numerical format, which if you see in a vector space, then similar sounding words or similar meaning words will end up close to each other. And that's what we call as semantic similarity. The words are meaning similar. Okay. And there are many text embedding techniques now, which will embed the text or embed the text in this. It means that it will generate a vector for the text or the, and it will try to keep the words semantically closer so that if you see them in the vector space, it will be close to each other. Similar meaning words will be close to each other. And there are many text embedding techniques out there. So bag of words, then word to vec. So this was the first technique that really changed the game. It was given by Google in 2013. So what would have been their thought process? I would like to emphasize on that. Let's say I ask two users or two people, how was Kabali? That Kabali is great. And the second says Kabali is awesome. both are meaning same, just the words are different. And let's say we want to assign some numbers to generate text embeddings. So let's say for Kabali, we start assigning these random numbers. For Kabali, we assign this 1.1. For Ace, we assign 0.5. And for Great, we assign 2.2. Now again, when the next sentence comes, for Kabali, since it's a repetition, we'll assign the same number. Ace will assign the same number 0.5. But let's say for Awesome, our random number generator gives minus 32.4. So these words are similar and also used in similar context also. Both are meaning that the movie is very good. But they are not able to capture this similarity between the numbers. Like Great and Awesome are assigned very different numbers. So with this, what people realized is that we cannot just assign some random numbers. Numbers should be assigned using some model so that it is able to carry the context or it is able to carry the meaning of the word. So earlier, how words used to be represented before this word to vec came, it was one hot encoding. One hot encoding is each word will be assigned a number. So let's say Kabali is assigned 0, is assigned 1, Great is assigned 2, Awesome is assigned 3. Okay. So we'll have 1000 as Kabali, 0100 as is, 0010 as Great, and 0001 as Awesome. One thing to note here is that it is just a hash map kind of thing to represent numbers, but it is not carrying any semantic value to it. Like with these numbers, if you see 100, you can say that Kabali is being represented, but it is not containing any extra information or semantic information is not captured here. So a good way to get these numbers in a way that it should represent semantic meaning is to use a neural network. So I'll just, with this example, I just try to show like, with this example, I want to show like how the embeddings are generated. Let's say, so we use a very simple neural network to generate embeddings. It will have input layer. Input layer can consist of words. Let's say we have 4 nodes: Kabali, is, Great, Awesome. Is it okay if I use board? Will you be able to see? Is this visible?
So we see the embedding slide. So are you showing something else, Samir?
No, I'm saying like if I show it on a board, will you be able to see like on my screen?
Let me put you on the spotlight. Let's see.
Are you able to see this part?
Yes, we can see, but it's too far. But this one should be closer. But let's see. Yeah. Or do you want to use Zoom whiteboard?
What is that?
Zoom whiteboard. So you have a whiteboard on the Zoom itself. Do you want to try that?
Is it? I have not tried. Let's try that.
Yeah.
That would be great.
So in the bottom, you should see whiteboards.
Where is that?
So in the bottom, you should see whiteboards.
It's inside the more option.
Okay, other participants. Okay.
More okay. Record, transcript. No, I don't see that. Slide control, annotate.
So Yogesh, do you see that now? Or you can try to use annotate. You should be able to.
Oh, annotate also works.
Yeah. So you can actually write on the same slide itself. Let's see. So whatever works for you.
Okay. So what I was saying is that once we are through this embedding, we'll see like how text is converted into vector. I just want to show what that vector actually means. So let's say this is our vocabulary. Kabali is great, awesome. I'm just taking a very simplistic example. So, and this is a very simple neural network. So one thing that I think I should have highlighted is that the earlier numbers were not able to show any relationship between similar words like great and awesome. Is great does not have just one meaning. It can be used in two contexts, or it can be used in many contexts. Let's say it can be used in two contexts like positive and negative. For example, if you ask someone, are you joining the video session today? Yes, I'm joining. Great. If you ask another person, are you joining the video session today? And he says, my laptop is broken, I won't be able to join. And the person replies, great. Both are different contexts. Like first is positive and the second is negative. So here I'm trying to say that, let's say this input layer has 4 nodes. And this is Kabali, this is, this is great, and this is awesome. Okay. And these first layer represents the number of contexts that a word can be part of. So let's say when in actual embeddings, what we do, we take a text and we convert into a vector of size 300, 400. So those 300, 400 are the contexts that that word can be part of. Okay. And then we'll join this, we'll join this. Now, what neural network does is, like in this case, what it will do, we are trying to predict the next word. So let's say if our input is Kabali. So let's say the input is 1, 0, 0, 0. It means Kabali is active here. What we want as output is the next word is. So if Kabali is active, what should be the next word? So it should be is. So the output should be 0, 1, 0, 0. And we'll have some weights assigned here. W3, something like this. Okay. So we'll train this network in such a way that given this input, we should get this output. And till the time we don't get that, we'll just run a forward pass, and seeing the error, will back propagate and keep on doing this till these weights are decided. So once these weights are decided, so let's say this joins here, this joins here. So this W1, W2, W3, as many contexts are there, that will be the text embedding for Kabali word. Similarly, for is, let's say it joins it, and it joins here as W22. So W11, W22 will be the text embedding for is. Is this part clear?
Yes. So team, any questions so far?
Like this part should be clear. Like if it is not clear, let me know. I'll tell again. Not a problem.
Okay, I would recommend to repeat once, Aman. Yeah, so I think Kavan has requested for the same, but yeah, please, yeah, go for once more. I think Bhargavi also asked for the same.
So what I'm saying is that we are going to use a neural network to create embeddings of the words. Okay. And these embeddings are going to be vectors. Vector like something like this. Wait, I'll show. So it's going to be vectors like this. Okay. For each and every word. So how do we generate these numbers? So we take a neural network, and for all the words that we have, let's say we are training our network on Wikipedia. So all the words that are there in the Wikipedia data, so the first input layer will consist of all the words that we have. Okay. And all the context that these words can be part of, or the context that we want to consider, will be part of the hidden layer. And we will train the neural network in such a way that for the sentences, each and every sentence, let's say we take this grade. Okay. So here we'll have 4 nodes. Let's say this is our data. Kabali is great. Kabali is awesome. This is the only data set we have that we are training on. So our vocabulary consists of 4 words. Kabali is great, awesome. Okay. So let's say I'm drawing these nodes. So this is representing Kabali and this is representing is. And this is representing great. And this is representing awesome. And like I told, each and every word, this is a positive context, this is a negative context. Let's say if we have some other text like we are talking about animals, so animal can be a context, then fruit can be a context, smell can be a context, humor can be a context. So like this, all the context that we want to decide. So the number of contexts that you decide will help, will make your neural network even more better. Okay. So this is your vocabulary and this will be the context. So the number of nodes you have in this hidden layer, the next will be the size of your embedding and the weights that are attached to these context. Let's say W1 is here, W2 is here, W3 is here. So Kabali's embedding will be W1, W2, W3 in the vector space. This is all I'm trying to say. And the way we train this is, let's say we take each and every sentence. Let's say we are taking Kabali is great. So let's say when the word Kabali comes, this neural network is going to be trained on predicting the next word. So when Kabali comes, it has to predict is. This will be 1, this will be 0, this will be 0, this will be 0, and the output should be 0. Kabali should not be there. After Kabali is should be there, and great and awesome should not be there. So this is the input, this is the output. So we'll train the neural network in such a way that for this input, it gives this output. And in this process, whatever weight is decided on this edge, these edges, those are the text embeddings for the words. Is this part clear?
Okay. So if I ask a question, then the vector size can be of any large.
Vector size will be as large as you have context in your neural network.
Okay. So in the neural network or the context that I pass to the model?
No, the corpus that you're passing into the model, you have only words and sentences. But you can decide how many contexts you want to have, like animals, fruits, good taste, then what else? Like many contexts, like let's say you have some text about the sun is rising in the east or the sun is beach. So beach and then fragrances, like you can have many context.
Got it. Okay.
Okay. So your input layer will consist of all the words that you have in the corpus, and this you decide. So what you will see that many embedding models have different size of vectors. So let's say if we use this, I think the smaller one that I have used in the examples is 354, is having 354 dimensions. So whatever are the context that you're using to club these words will be the size of your vector, and the weights decide the values. This is all I'm trying to say. If it's clear, it's fine. Otherwise, we'll just move ahead. I think it's not that important also, but I wanted to make it clear.
Yeah, that is okay. So we have got one other question from the participants. So Devardhan has asked, so edge is like a vector weight.
Sorry, I didn't get that. This
So-
you're saying?
Yeah, so edge is like a vector weight.
Edge is like a vector weight. Correct. That is correct. Edge is whatever the value, whatever the weight this edge is having. value of the vector for that dimension.
Got it.
Okay.
Great.
So is there any other question? I should see the chat.
No, so that's the only one. Yeah.
Okay. So
So,
edge is
yeah.
like a vector weight. Edge is like a vector weight. Yes, you can say that. Okay, so this word to vec paper, this was the first work towards this linking words semantically, and this was given by Google in 2013. And the goal of the paper was to words that are used in similar context should have similar embeddings. Similar embeddings as in they should end up close in the vector space. And they trained it on the data sets of Wikipedia data and Google News. So they used two extra strategies. One was continuous bag of words. So with that, what they used to do, like the surrounding words will predict the center word. Say Kabali and awesome will be used in predicting the center word, which is. And skipgram. Skipgram used to predict the surrounding words given the center word. So this was used for most of the words and it was quite fast also. But skipgram, since it is the center word and it is trying to predict the surrounding words, it was very slow. So this was used only for rare words. And once they trained it, they were able to capture words which are uh, which are having which are semantically same. They were able to land those words in uh, close enough in the vector space. So if you see this results, if you see this cluster, is my mouse visible?
Yes. Yes.
Okay. You see here Sunday, Saturday, tomorrow, Thursday, Wednesday, December, November. So all these related to day and time, these words are clubbed together. Similarly, they were able to capture these words, which are semantically closer. They were able to capture it closer in the vector space also. So this was about word to vec, but in sentences. So for sentences, we have sentence transformers. So the problem with word embeddings is that it embeds only the individual words, not full sentences. So these sentence transformers are special models that will embed full sentences in a way that semantically similar sentences will end up close in the vector space. So it will try to capture the essence of the entire sentence rather than individual words. So let's say these Kabali is great and Kabali is awesome, semantically similar sentences. So the embeddings that will be generated for these sentences will also be similar, like 1.2, 1.1, 0.7, 0.8, minus 0.3, minus 0.2. Okay. So I'll just show one example. What do you see like right now?
So,
do you see my slide in a
we see your PowerPoint. Yeah.
in the full screen?
Not in the full screen, so we can see all the screens.
Okay. So do you see these tabs, individual tabs, Google Chrome tabs, Colab, Advanced?
No, we can see you are hovering over, but we don't see the tabs. Can you switch between tabs? We see if you're actually getting changed.
I'll share again. Google Chrome. I'm sharing Google Chrome. I think it should be visible. Okay. So are you able to see this?
Yes.
Colab?
Yes, we see the Google Drive. Yeah.
Okay. So all the demos that I show here, if you also want to try, so what you need to do is go to your drive, click new, go to more, and you can use this Google Collaboratory, Google Colab. So this is like a cloud hosted version of Jupyter Notebooks. So all the Python runtime and certain GPUs are also available in that. And for smaller experiments, this is free of cost. So here I'm trying to show you the generation of embeddings, text embeddings. So here, if you see, first we install the libraries that are needed. The most important one that you need to see is this one, Word2Vec. So this is available in gensim.models. So even though the name is model, this is not a model. This is class. So what I mean is that it's an empty model. So if you pass any words to it, it will generate certain numbers, but it won't be semantically close enough. So if you want to use this, you will have to first train it on a large corpus. Then, but the neural network, so this Word2Vec contains the neural network. So it will be able to then capture the semantically closer words together. So here I'm passing these sentences. Cat sits on the mat. Dog sits on the rug. Fish swims in the water. Bird flies in the sky. Okay. And I'm using this Word2. So what this means that we are going to train Word2Vec model on these sentences, and vector size is going to be 100. Vector size in the sense like the embedding that it should generate will be 100. It means that we are trying to convey that we will only capture 100 context in our model. And window equal to 5 means when you train this model, each and if whenever you take a word sits, you should see 5 words right to it and 5 words left to it to derive its context. Min count equal to 1 means that even if a word has occurred once, entire vocabulary, that also you consider. Workers equal to 2 is referring to that use 2 cores, and this is a random seed. So using this model, we try to generate the embeddings for this. So if you see here, the embedding for cat is like this. So we are printing only the first 10 values, but it would have generated 100 dimensions. But 100 dimensions do not matter here. I think if the corpus is large, then it will mean a lot. So how semantically similar these vectors are, we can find it using. So if you see here, we are trying to find the cosine similarity between fish and dog. So the thing with cosine similarity is that if the value is large enough, like if the value is 1, it means the words are very similar or exact. And if and 0 to 1, if it is positive, then it means that they're kind of similar. The more positive the value is, like let's say 0.9, 0.8, 0.7, it means the words are quite similar. And if it is going towards negative, it means that they are quite opposite. They should not even be considered for similarity. So if you see here fish and dog, they end up like 0.0030. It is at least positive. But if you see cat and sits, noun and the second is a verb, there's no correlation between them. And if we try to see, so the thing that I highlighted was that this is just generating embedding. The model is not yet trained. It is just generating some embedding for you. So if you see dog, fish, cat, bird are here, as we increase our sentences, they will start coming together as a cluster. Okay. And these verbs, fly, sky, sits, they will also start coming closer as a cluster. So this is an example of word. So converting text words into embeddings so that similar words can be close enough or can be part of some clusters. We can have clusters of similar words. Okay. Now, second example is.
Someone, there was a question around why did we fix the vector sizes 100?
No, it depends. You can have it 400 also. Let's say if you have a Wikipedia data set, you can have it 400 also. The computation will increase, and you will have to spend good amount of time and good amount of resources to train it, because the layer in the neural network is increasing. So accordingly those matrix operations will increase. So you will have to have more compute power. So that's what I was saying. Like in the example that I showed, we could have dimension as 5 or 10 also, because we had only 4 sentences. But let's say you are training on a data set of Wikipedia or very huge data set, then the number of dimensions should be quite huge if you are trying to capture the context.
So we'll get better accuracy. The number goes high.
Number goes high, you will get better accuracy. That is correct.
It's based on the training purpose. Yes, sir.
Sorry.
It's based on the training purpose.
It's based on the
Like for vector size would be 100 or some other thing.
it's based on the training purpose. Yes. For now, our neural network, we are aiming it should predict the next word.
Yeah.
So that's why we are trying to be semantically sounding or semantically similar words together.
Yes, sir. And also I have one another doubt.
Yes.
Could you explain the cosine similarity?
Cosine similarity, I think you can look up online once, because cosine similarity is like there are two vectors in the space, and we try to use the angle between them for the similarity. And
Okay, okay.
if you see this cos 0 is 1 and cos 90 is 0. Okay. So if if they are forming this acute angle between them, the more acute angle or the more close they are, the cos theta value will be greater. This is
Yes.
how you find, like, I think better explanation you can get in online.
Yeah.
Because so there are multiple measures of similarity. One is cosine similarity, then you have this dot product. So in cos, we see the higher the value, the similar the vectors. In other similarity measures, this will differ. So the higher the number, it means the numbers are far from each other. The vectors are far from each other. And second could be Euclidean or L2 distance. You can see the distance between two vectors in the space. So there are many similarity things, but cosine is one of the most popular similarity measures that is used. And also for text, it makes much more sense. So that you can look up online. But you understand now, like, let's say this is the vector space, this is one vector, this is second vector. Okay. The
Yeah.
closer they are, cos theta value will be higher for that. And that's how we derive that these vectors are close enough in the vector space.
Yeah. Thank you, sir.
But if you want much more mathematical explanation, I think you can look up online.
Yeah, sure.
So this one I'm showing, like, so sentence transformer is a model. It is a trained model. Okay. The word to vec was a empty model that we were trying to train, but here sentence transformer represents a trained model. So here, if I give these sentences to it, apple is a fruit, cats are wonderful pets, Python is a programming language, I love eating bananas, dogs are loyal animals, it will be able to embed these sentences in a way that it lands up exactly where the model should land this up. Okay. And once these embeddings are generated, if I give one more query and find what is the sentence that it is close with, what I'm trying to say is, like, let's say I'm giving these sentences and I'm saying, oh, sorry. I think I deleted something. 1 minute. I think you can look here. So let's say we have these. So we are loading a trained sentence transformer model, which is trained on a large corpus, let's say, okay? And we are giving these sentences to it. Apple is a fruit, cats are wonderful pets, Python is a programming language, I love eating bananas, dogs are loyal animals, Java is used in backend system. So here, if you observe, Apple is a fruit is quite similar to I love eating bananas because both are talking about fruits. Similarly, cats are wonderful pets and dogs are loyal animals are talking about animals. So these sentences are also semantically closer to each other compared to the other sentences. And if you see this, Python is a programming language and Java is used in backend systems. So both these sentences are also talking about software. So this is also and so these sentences are also semantically closer to each other. So now I am embeddings for this. Now, if I say that actually this is example of vector database. Okay, so now if I ask like if I give it a new uh, if I give it a new sentence like tell me about pets, okay, so here it is trying to find what are the uh, semantically closer sentences documents that is close to pets. So when it asks tell me about pets, the top matches that it searches are cats are wonderful pets, dogs are loyal animals. Similarly, what we do in RAG is that when we get the query, that query we embed and then we try to search in the vector space and whatever closer sentences are there that we so top case sentences we take for the retrieval part. So is this clear? Like it's not the exact example that I wanted to show, but I think somehow I messed up. Here, I think there should be some more changed something maybe at the last moment. So, but is this part clear here? Like these documents, we are embedding in data in we are embedding it in the vector space, and Apple, bananas are close enough, cats and dogs are close enough, and Python and Java are close enough, and we are trying to see what are the sentences that are closer to pets. So it is able to fetch this cats are wonderful pets and dogs are loyal animals. Is this part clear?
Yes, sir.
Okay. So now we'll have a small quiz for embedding. Just see whether you are able to access this link.
Yep. So all of you can actually get the link from the group chat that I'm just posted. Read out and give a thumbs up once you're able to access the link. Three people. Yeah, if you're able to access, just give the thumbs up so we know you're all actually in there. Now, but, um,
Is it over?
I see around 7 people reacted, but I think most of them might have opened up as well. So I think we should get started, Daman.
Or we can discuss here only. Let's discuss.
Okay.
Okay.
Yep.
So the first question is, what is the main purpose of embeddings in machine learning? So if you want, you can unmute yourself, and if you would like to volunteer to answer, that also should be fine.
Yeah, another preferred ways you can also post in the chat.
You can post in the chat also, yes. So most of the people are saying B. So to convert text or data into meaningful numerical representations. Okay, so that is correct.
To join them.
So now the second is, which of the following techniques generates embeddings for words? Not full sentences. So the first is sentence transformer, second is GPT, third is word to vec. So most of the people are saying C, word to vec. Okay, fine. Now in the word to vec model, which method tries to predict the center word from the surrounding? Skip gram, fast text, or transformer encoder? So Satya said D. What did you say D? Did you mean this transformer encoder? So there were two techniques in word to vec. One was continuous bag of words, and the second was skip gram. Continuous bag of words tries to predict the middle word based on the surrounding words, and skip gram will take the center word and try to predict the words surrounding it. A. So now, what advantage do sentence transformers provide compared to word to vec? They create smaller files. They embed full sentences, not just words. They use fewer resources. They visualize data automatically. So question for B. Everybody's saying they embed full sentences, not just words. I agree with you. Now, if two sentences like Kabali is great, Kabali is awesome have similar embeddings, what does it indicate? They have completely different meanings. The sentence length is the same. They were randomly assigned numbers. They have similar contextual meaning. No, C is wrong. So that's what I told. Like initially we started with randomly assigning numbers, but then we used a neural network to train it in such a way that the numbers are generated to represent semantically similar text together. So that random thing is gone. Initially we start with random numbers, but then the neural care of converting those numbers into meaningful weights. So the answer is D. Okay, so far the session has started on a low note because it was little technical, and if this would have been a board session, I would have been more comfortable. But I think the essence that I'm trying to say is that each and every text is represented in the form of numbers. Earlier, it was not possible to represent numbers. That's why we were using one hot encoding, which was like assign 0, 1, 2, 3, 4, 5, like these these indexes to the numbers, and have a very big vector. One will be there to indicate the word is there, and rest all fields will be zeros, and that will keep on repeating. Okay, and that was not able to capture the semantic similarity essence of the words. First paper that tried to solve this problem was Google's word to vec, where they generated textual embeddings or vectors for the text in such a way, and they were able to get the weights in such a way that the similar words will end up similar in the vector space. And from there, the work got extended to sentence to embed similar sentences on the vector space such that similar sounding sentences end up quite near. So with this, what I'm trying to say is that let's say you have a document, okay, and you embed that document in the vector space. Now, if you ask a question, let's say the document is about uh, life of Mahatma Gandhi, and you have embedded the sentences there in the vector space. And now I ask the question, where was Mahatma Gandhi born? So it should be able to find the similar context word from that document and to the LLM. So this is the importance of this sentence transformer. And this was the importance of like why I wanted to convey this first two things as this embeddings and this word to vec and sentence transformer. So is it clear now? The link, like what we are trying to say, it was not just random topic that we just wanted to highlight. I just wanted to let you know these embeddings, and also like telling that embeddings are just numbers. I also wanted to make it clear like how those numbers come up. It comes from the neural network and the weights that are going from the words to the context in the hidden layer. Is this part clear?
Yes, sir.
Okay. Any doubts so far? No. Okay.
So I was actually, yeah, this is clear. Definitely, even who had zero knowledge on these aspects, it's very clear. They're able to grasp the basics of it. Basically, I was. And so I was actually looking at your demos and notebooks. So can you share the gist of it or somewhere so that we can actually take out and try those?
Sure. I'll share that. So I'll share that. Also, I told like how can you also run it in your own drive. So if you find like you're not able to run, let me know. I'll share all the notebooks at the end of this session so that you are also able to run it in your environment.
Yeah. That will be everyone interested for sure. Yeah.
So now embedding is clear, I am hoping, and or at least the essence of embedding, you now know what embedding is and what sentence transformer does. So now we'll move on to this vector databases. So now that we have embeddings for the this 1 minute. Yes. So now we have these embeddings, large numerical vectors we have for the sentences. So how should we store them? Now that is the question. How should we store them in such a way that we are able to retrieve them easily, search them, and so or why this new database is coming up in the picture at all. So if you take these like I'm just trying to make you understand that this word traditional databases like RDBMS, they work on only keyword search. Okay, so you have multiple rows and multiple columns, and you say that select a star from there where this is like this or this is having this, so on and so forth. So let's say we have an image here and we have textual description of this image is rising over the mountains, something like that. Okay. So if we try to store this in a relational database, what best we can store? We can store it in the form of a blob, the image, and then we can include some text for it. Text as in like sun is there, mountains are there, sky is there. That's it. This is the best we can store with. Okay. Now, let's say I have many images like this, like sun is setting on the beach. That also we stored like a blob and those keywords. Now, if I give a query that find all the images that has orange color in it. So that cannot be solved by relational databases. Okay, so it cannot find, even though the question is very legitimate, or if I say that give me all the images which has sun in it, okay, so it will not be able to find. And this is what semantic search is all about, like human search like this only. So that keyword search is restricted to this, or RDBMS is restricted to keyword search. But if you want to go for semantic search, then we need different database for that. And so far we have seen that we need different representations, which is in the form of embeddings. And to search those embeddings in the vector space, we need different databases, which is vector databases. So vector databases, they will store these high dimensional vectors, and they will give us CRUD operations so that we are able to search the nearby vectors very easily. So that's why vector databases are important. Okay. So key features are it can store billions of vectors, and it can search based on distances, cosine, Euclidean, or dot product. It is fast and scalable. And how does it work? It tries to find the, so let's say if we give some query, it tries to find the similar vectors to it and most similar vectors to it. And one way, one very popular algorithm that gets us these nearby vectors is called KNN, K nearest neighbor. But KNN might not work when billions of vectors are there. That's why we used approximate algorithms here, which is HNSW and IVF, graph-based multi-layered indexing and cluster-based indexing. So cluster-based indexing is like we divide the vectors into multiple clusters, and when we get a query, the most similar cluster or the query, we match it with the clusters, and the one cluster that it matches quite fine, we will search only in that cluster. We'll not worry about the other clusters. And HNSW is similar to like uh, we'll have multiple leaders of the cluster, and we'll talk to only those leaders. And whichever leader says that part of our cluster, we will take that. And popular vector databases are FAIS. This is by Facebook, Facebook AI Similarity Search, then Pinecone, Chroma, VV8. So I'll just show an example of this. Actually, I was showing an example of vector database only in the previous demo, which I was showing. So if you see this one, are you able to see this, Colab?
Yes.
Okay. So here we took these statements and we created the embeddings. Then we index all using this FAIS database. Okay. And we are asking it, like, what are the vectors that are close to pets? Tell me about pets. So here it is able to fetch that cats are wonderful pets and dogs are loyal animals. It is able to fetch that these are the sentences that are close to this. Tell me about pets. So this is a simple example. I think there is one more database called Cosmo.
Yeah, Azure Cosmos.
No, not Cosmos. Sorry, that is, it's very popular. I think I have not.
Okay, so Postgres they were recently introduced.
Chroma.
Oh, okay.
Chroma is also very popular. So it's very light also. So I think you can have try Chroma or something like this. Chroma vector database. So if you want to, so this one, trychroma.com. So this also you can try. It's a very famous database. But the good thing about FAIS is like Redis. Redis in the sense that it will not have any store. It is just an in-memory database, FAIS. Chroma will store its file in the file system or whichever that you give it. It will actually store the content. But FAIS is like that Redis cache. So it will store only in the memory. Okay. So now the only thing that you should take from these slides is like we have text embeddings, which are in the form of big vectors. We need some form of database to store these vectors. And for us to do this crude operation, we should be able to find the similar vectors. We should be able to read, we should be able to store them. So for that, vector databases are there. And the popular databases are this. This is the only thing that you should take away. Okay. For vector databases. Is everyone ready? Let me open my chat. So the first question is everyone ready? Okay, yes comes. Okay. So we have the first question. What type of data do vector databases primarily store? Text documents, key value pairs, embeddings, images. Embeddings. Okay, perfect. And which of the following is not a popular vector database? Pinecone, FICE, Redis. Someone said Redis, which is wrong. Ram. Achha, I did not tell this. So Redis has a version of vector database also. Okay, so the correct answer is this PostgreSQL.
Oh, really? They have recently introduced vector database as well.
Yes, yes. Redis has a vector database version also.
Yeah, okay. Nice.
So now vector databases help us improve the retrieval step in RAG. What do you think? True or false? True. Okay. Which operation is most commonly used to find relevant vectors in a vector database? Sorting, clustering, similarity search, text parsing. Okay. So C, similarity search is the right answer. So I see only 3-4 people answering. The rest are not participating, or because I still see 19 participants. So now, which of these best explains how a vector database is used in an LLM pipeline? It replaces the language model. It stores and retrieves semantically similar context for queries. It translates natural queries into SQL. It compresses documents for storage. Okay. B is the right answer. That is fine. So now one question, I think one or two of you will have to answer. So the question is like, did you guys know vector databases and embeddings before, or is it just based on the content that you are able to answer? Because most of the answers were correct. That's why I'm asking. Anyone can speak based on, oh, is it that good? Okay. Okay. Perfect. Perfect. Okay. Okay. That I'm speaking the obvious, like, then let me know. We can skip that also. If you already know something, we can skip that also. So now comes RAG. So RAG, I already told you, a query will come from the user and will try to find the relevant uh, content or relevant text or relevant data for that query from an external knowledge database, which will be stored in vector database. And using that query, LLMs will generate your answer. Okay. And it helps LLMs answer question based on up to date and domain. So that is already covered. Okay. So retrieve relevant information, provide it to the LLM and generate accurate answers. So Ram was mentioning that this hallucination and this what RAG lacks and what is the limitations of LLM being trained on old data. So I think that was discussed in the last session. So I'll not talk much about it. Okay. But I think this diagram will be able to answer. So this is a standalone data. And let's say we have a system which is a e-commerce store, and we are having an LLM as a chatbot and an e-commerce store. So if we only have this LLM, and if the user is asking what was my last purchase, so definitely it will not have updated information to answer this query. While if we have RAG integrated with the database, and the user asks what was my last purchase, it should be able to get data from the orders table, and it should be able to answer your last purchase was a Bluetooth speaker on October 15th. So especially in this real-time information is, let's say if I want to find what is the price of gold right now, what is the Bitcoin price right now. So, or let's say a doctor is using LLM uh, to study his vitals. So he needs the current vitals. So all these systems that require this real-time information as a must, they will have to have RAG. So some people argue that this RAG is only relevant till the time this training is expensive. Now that DeepSeek came, so if the training becomes less expensive, then we can keep on training models again and again. And let's say that happens, training becomes so cheap that you are able to train every week. Then also for the systems that we are discussing, these that require real-time information, still RAG is required. So RAG will be relevant in a long run. So if you learn RAG, that will be good. So there are basically three types of RAG systems. One is naive RAG. Naive RAG is the one that I already told. Like just query is coming, find the give it to LLM, it will augment and give you the answer. But what people saw was that if you deploy such an system online, then it is not good enough to be deployed. Like it's not generating answers to the to the extent that an LLM should answer it is not able, or basically an LLM is not able to generate answers very accurately, or the content of the answers is not great. And then the third is agentic RAG. So we'll first start with naive RAG. Naive RAG I have already discussed. So what it will do, you will have a query. It goes through an embedding model, and then you get this embedding of that query. Then you search that in a vector database. Vector database already has the document or whatever you require, like all the text documents you have already fed to the vector database. So it has the data that you are searching for, and with the similarity search of your embedded query, it will be able to find the chunks that are relevant, and that chunk along with the query will be passed to the LLM. It will generate the results for you. So one thing here is that it is for uh, simple FAQs, not much detailed reasoning questions. So this is what the problem with naive RAG is. Okay, so we'll see the advanced RAG now. Oh, we'll have a quiz now. So this part is clear. Like I'm not going much because I think right from the start we have built this intuition what RAG is. So I think this part should be fairly clear. I'll again open the chat. Okay, so is this part clear? Because we will now go into the quiz for RAG, and then we'll start with the advanced RAG. Okay, Sriram says yes. Okay, Kavya Karthik says yes. Satya also said yes. So we are assuming it's a yes. Okay, so everyone is ready for the next quiz? Yep. So we'll have the first question now. So what is the main goal of RAG? replace language models, improve inference speed, enhance generation using external knowledge, store training data. So everyone says C, Kevin says B. Okay. So it is not improving the inference speed. It is just giving us data. Okay. So Kevin, you have any doubt or? Okay. Next is which component is responsible for text in a RAG system? Tokenizer, retriever, generator, agent. Okay, so variety of answers here. A, B, D. Only generator people did not answer. So in RAG, we take the query and we go to the vector database and retrieve the relevant chunks from the vector database. So retriever is the right answer. So there's a module called retriever that retrieves the relevant chunks of data from the vector database. So the answer is B. D can also be the answer if you have many data sources and you want to decide which data source should I go and fetch that thing. Then agent would be a much better answer. So since D so far, so that's why it's not the answer. And it will be an answer in a broader context, like when you have, let's say, 5 data sources and you want to decide which data source my data might be in. So that time agent might play a role. But even though it plays a role in deciding the data source, if the data source is vector database, retriever will be the one that will go and retrieve the relevant chunks. Okay. And tokenizer's job is not this. I'm not sure if tokenizer was discussed in the previous sessions, but tokenizer job is to convert the text into relevant tokens which are understood by the LLM. So RAG systems need to retrain the LLM after adding new documents. True or false? Perfect. Everyone is saying false. Now RAG can help reduce which common LLM issue? Overfitting, hallucinations, training time, latency. Okay, everyone is like hallucination. Okay, hallucination should be the right answer then. What is typically stored in the RAG retrieval layer? Documents, token embeddings, vector representation of chunks, training logs. So Shashi, A was for what? A is for overfitting or raw documents? Because in either case,
A is for overfitting, but
okay. So do you have any question regarding this, or is it clear this
yes,
hallucination?
yes, that is not clear. Like why it helped hallucination?
It helped hallucination because so hallucination is like the LLM do not know the answer, but since it can generate some sentences, it will give you dummy sentences. This is what hallucination is.
Okay, so it is hallucination is something like it is assuming, and since RAG gives the data for the assumptions, it is avoiding hallucinations. Can I take it like that?
Correct, correct. So hallucination is like LLM is not aware of the answer, but it is just generating some sentences. Hallucination is not visible to ChatGPT first came in 2022 end or 2023. That time
Ah.
hallucination was very much visible. When you ask
Yeah.
any question that it is not knowing or
Yeah.
data it does not have, it will generate some text which will be irrelevant, but it will seem like properly framed sentences. So, so why hallucination happens? Because LLM do not know about it. And what RAG is helping is, it is providing the data that will be helpful for LLM to form the answer. So that's why it helps us in removing hallucination. Overfitting is a different issue. Overfitting do not come here.
Okay.
And for the last C, so far we have got correct vector representation of chunks. That is correct. So any questions so far? No. Okay. So we'll see a small demo of RAG. So we give this, so let's say this is my data source. This list of statements, the Eiffel Tower is in Paris, the Great Wall of China is visible from space, pandas are native to China, Taj Mahal is in India, Python is a programming language. So the last one I added just in case you feel like, since we are already using a LLM, maybe it will be trained enough to answer these. Like if you ask any question out of these, then it should be surely be able to answer. So that's the reason I included this last. So I'm very sure that LLM might not know VDL sessions are conducted from Coimbatore. Okay. So now we embed this store in vector database, and then when we give the query where is the Eiffel Tower, it should be able to find the uh, near statements that should give this answer, and embed that with the query, and it answers it perfectly. So I'll just run it once. I think it takes a little bit of time, around this will take few minutes for it to load. But the essence here is, when we ask where is the Eiffel Tower, it will look into the vector embeddings and find the closest sentences, like Eiffel Tower is in Paris, this one. And I think then Great Wall of China, not Great Wall of China, I think the Taj Mahal is in India, because here we are talking about monument and its city. Here also we are talking about a monument and its city. So these will be much more semantically closer in space. So if we take the top two vectors, these two vectors should come. If we take the three vectors, maybe this Great Wall of China can also come. But we are taking only two sentences closer, two close sentences. So I think this Eiffel Tower is in Paris and Taj Mahal is in India will come, and these two will be embedded along with the query. And we ask this when we ask this question, the answer will be that Eiffel Tower is in Paris. Similarly, I think this one I ran. So where is the Vidyal session conducted? So for this, the top documents that it fetches is that Vidyal sessions are in Coimbatore and the Taj Mahal is in India. Okay. And the answer that it gives is Coimbatore. So this is a basic RAG. So instead of this, like here I am hard coding the sentences. Instead of this, you can load a PDF also and try to make it work. It should work fine. Actually, I was trying one demo. I'll share these collabs with you. So if you see this naive RAG FICE PDF, so what it wants is, like, you should have the PDF on the drive and you have to give a lot of permission for the drive. So this permission you need to give. So I was not able to give that much permission because it was asking for all the images, uh, all the videos, everything it was asking, all the text files. So I tried to give like few folders permission, but this example should work. So you can try it out in your local Jupyter notebook, or if you are happy sharing all the contents of your drive, then maybe you should be able to run this Colab. So in this, you just have to place your PDF in this content drive, and you can then start querying your PDF, like what is the main main subject in the PDF, what is that this PDF conveys. Like this, you can have questions.
So, in your slide, you showed how a naive RAG will usually, that architect. Can we compare this to the code? Like which part does what?
Yeah, we can compare. So the query, so there are two parts to it. One is phase one, second is phase two. Okay. Phase one, what happens? Phase one is this construction of this database. So all the documents you have, or all the information that you have that is not part of the training of LLM, you feed it to the database. How that happens? You give that content, it gets chunked, and those chunks are then stored in the vector database in the form of embeddings. Okay,
Okay.
so this is phase one. Second
Okay.
is when you give query is also embedded using the same model, so that it lands up somewhere in the same vector space.
Okay.
Okay. Now, when you get that embedding for that query, now you are searching in the database that in this vector space, one minute, I'll use this annotate. So let's say this is your space, and the chunks that you have already given are somewhere here. So these are chunks that you have given, and some are, let's say, here. Okay.
Mhm.
And some are, let's say, here. And let's say your query lands up, let's say, here. Okay.
Okay.
So then this KNN algorithm, where it will fetch the top K similar element. So maybe it will try to fetch these chunks of data,
Okay.
and this chunk will be embedded with your query. So
Mhm.
okay, and the query that goes into your LLM is the question that you asked, along with the relevant chunks that it was able to fetch.
Okay.
Okay, so it goes like, where is Eiffel Tower? And the content that is going along with that is Eiffel Tower is in Paris. Taj Mahal is in India. So with
Okay.
that knowledge and with that query, since it understands the pattern of language formation, it understands the language, everything, it is able to answer. So if you see here, so this was basically. So we are using this embedding model,
Okay.
LM L6V2. So it's a very small embedding model, which will have 354 dimensions, I think. I think we can search also. 384, sorry. So
Okay.
this produces 384 dimension dense vectors. So what is the
Okay.
meaning of this 384 dimension? It will embed the sentences in 384 context. Okay.
Understood.
Now we have these documents. So using this embedder, we are embedding these embedded. So let's say if it is embedded, so let's say Eiffel Tower goes here, let's say. This is your Eiffel Tower. Okay.
Hmm.
Oil of China, let's say, since it goes here. Pandas are native to China, let's say, goes here. Taj Mahal is in India, goes here.
Mhm.
Python is a programming language, goes here. and VDL sessions are conducted in Coimbatore, it goes somewhere here, let's say. So we are embedding these documents, and now we are creating an index out of it. So we are using this vector
This
database.
model, this embedder is the model. When it loads, it is actually loading all the embeddings, and when embedder.encode means we are also just putting these dots also into that embedding.
Correct. So embedder is a model, pre-trained model, which
Okay.
knows where to place what. So it is already trained.
Okay.
Okay. And when you encode these fresh statements, so it knows that if this is the form of sentence, then it should land up here because similar sentences are already here.
Yeah. Okay.
Maybe Python went here because Java is here, C# is here.
So when you say encode means it is again, it is we are giving words, it is already converting into vector and doing everything under the hood.
Yes, yes. So this is what I started with. I started with word2vec, which was a model to place words into vector spaces. But then we moved to sentence transformer. These are special models that will place your similar sentences in the vector space, close enough.
Okay.
Okay.
Sorry, I joined late then. Missed the part.
Oh, you joined late. Oh, no problem.
Okay, sorry then.
No problem. So now you're using this FICE database to index all these embeds. And then when the query comes, where is the Eiffel Tower? So you are encoding this query also using the same embedder. Okay. And here we are searching like this query is similar to what in this vector space.
Okay, got it.
And then it comes up like since like this is taking this run. So we can run this. So generally this step when you are including this transformer and this loading of little time. So ideally what will happen is like here you will so here you'll be able to get the nearby vectors.
Okay.
Okay. And then your context will be like your query along with this matches, whatever matches you got. So this you will give to your LLM answer based on context this and query this. And then LLM will take this context. Context means this similar data and your actual query, and it will answer based on that. So here, when the question is where is the VDL session conducted, top documents are in Coimbatore, Taj Mahal is in India, and then answer it is generating is Coimbatore. So how the answer will look like, LLM already knows. It knows the formation of sentences, everything. All
Okay.
whatever it is not having is the data, relevant data. I think it's also ran. So we'll load this. So here, when we ask where is the Eiffel Tower is in Paris and Great Wall of China is visible from space. So I was expecting maybe Taj Mahal is in India will end up, but I think it is taking this China thing as to be similar. Okay, which is also fine as long as it is taking this the correct. So my understanding was that Eiffel Tower is in Paris and Taj Mahal is in India are very similarly formed sentences. So maybe they will end up very close in the semantic space. But let's say if we change this k equal to 3, na, I think Taj Mahal might come.
Okay.
We'll change this. We'll try to run again. So you see, third is Taj Mahal is in India. So not sure why it took this. According to me, like logically, it should have taken this, but maybe because of the training, it would have taken. Okay. but logically you are able to get, no?
Yeah, I'm able to get. Thanks.
Okay. So now the question was, where is the Eiffel Tower? And the answer is Paris. So far what we were seeing was that these are the documents we had, and with vector databases we can find the similar sentences, but it will give you all the sentences. Like it will not be able to extract answer out of it. To extract the answer out of it, you need an LLM. Okay, so we are using this Google Fluentify base. So this is a sentence to sentence generation, this thing. Is like text to text generation model. So I'm not sure if you have used this, but we used to use this to convert sentences to SQL queries. So we were training Fluentify. This is a base model. We used to use Fluentify large, and we gave it a huge corpus of text to SQL, and it was able to generate quite good results in that. So we are using this LLM. Now when the context goes and the query goes, it is able to generate this answer. Okay.
Okay, great.
Okay. Anyone else having any doubt? I think this is the right time because it's almost 11:50. I'll open the chat.
So we have got a couple of questions, Aman.
Like more than couple.
Yeah, one question and another one is to share this file. So that is anyway we are going to share it at the end. Yeah.
So can we run this with Olama? Olama, you can run local LLMs with Olama. I'm not sure if you can run the Jupyter notebook with Olama. I think in this part, in this 12th section, when this model, I think Olama will help. Could you please share? Yes, we will share. So I think Sham was asking. So in Olama, I think you can have direct Python you can run. Why you need this Jupyter notebook? So Olama basically is a tool that helps you run these local LLMs. So it will look something like this. I should have Olama running in the local, but I think it's okay. So you can go to olama.com and you can download Olama, and then there are very easy steps to load the model and run the model. So you can run Llama 3 or Mistral, like
Hello,
these.
hi sir, Sham here.
Sham, please tell.
Yes, so actually, exactly my doubt was that. So, are we running this the model you were showing right in the collab? Is it running on the CPU itself, or do we are we running it in cloud or something?
No, so in the Colab, the Google Cloud environment is giving us these models.
Okay.
The models that you see here, or the Python environment that you see that we
No,
have.
do we have to pay for this, or
No.
is
This
it
is
like?
free. This is free.
Oh,
Like
okay, okay,
these small experiments are free. So
okay.
you can take a pro version also. For the free version, I think you can access this 12 hours, not more than 12 hours. So let's say you start a experiment and it keeps on running more than 10, 12 hours, then
Okay.
it will be disabled for a day. And
Okay.
I think
Again, we can use it in the next day also.
then you can use it next day. So 12 hours it
Okay.
takes limit. And second thing,
Okay.
I was about to say something. You will not have access to the high-end GPUs. So if you
Okay.
need high-end GPUs, then you will have to take the pro version. Otherwise,
Okay.
these small experiments, whatever I showed, you should be able to run this collab free of cost.
Okay. Yeah, that was my idea.
If you don't like, you can find like new, more collab. If you don't see it here, then you will have to add it. So connect more apps, collab and add it. That's the only thing.
Okay.
So here you search
Yeah, I will
for
try this. Yeah.
collab, and then install it, it will start appearing.
Okay, sir. Thank you.
Okay. So is it okay if I break for like 2 minutes? It's
Yes.
11:56. We'll join again at 12 and we'll try to finish everything in one go. So far, like whatever the session has gone, was it meaningful and informative, or I was just stating the obvious? I think answers one down.
Yes, so people are actually posting the chat.
Okay. As long as it is informative, I'm adding something, then it's fine. Okay, I'll break for 2-3 minutes. I'll be back at 12. Okay.
Super. Thank you, man. So we'll stay on and we can catch up at 12. Yeah.
Yeah, just 2 minutes. I'll just break for washroom.
Sure. Yeah. So, so we all back, team? So we can actually get started. You can put it in the chat. So
Shyam is back. Karthik is back. So Satya will discuss your question at the end of this session. We'll try to understand what the question is. Okay. Kavya is back. We'll start at 12:05. Okay.
Sure.
Meantime, they come, I'll just show this image to you. So is this image visible? I'm sharing one image. Is that visible or not?
No, we see the PPT.
PPT only. Okay, wait. Share. How about now?
Yes.
Is still PPT?
No, we see the image now.
Image you see. Okay. So when I think Shyam asked the question about this naive rack, I'm just telling what I have already told. I think meantime others will join. I'll just emphasize something. So when Shyam asked about this naive rack, like can you show the code that is there? So I told that there is one phase one of uh, phase one which happens before, and then phase two is the runtime when the query comes. So if you see this, what happens, like all the documents that we want to supply for LLM will store them in the vector database. But how it happens, like you first parse them and then you separate and then you create chunks of the data. Let's say I am trying to store a book. So I'll create chunks like chapter one, few paragraphs, then few paragraphs, then few paragraphs. Like this, I'll create chunks. And then chapter two, like let's say 20 paragraphs from chapter 2, 20 paragraphs from chapter 3. Like this, I'll create chunk of text. Okay. And that I will feed it to the LLM. Sorry, that I'll embed. So now we are going to study is advanced RAG. So I'm just telling because when I was explaining naive RAG, I told that naive RAG you cannot use in production as such. What is naive RAG? Just have a vector database, store your data in vector database, and embed your query, find the relevant chunks, give it to LLM, it will answer. So that is naive RAG. But what happens, like how you are chunking this data, how you are embedding this data, each and every step, whatever you're doing in naive RAG, it plays a very important and it starts giving problem. So when you see the example of naive RAG, we were expecting uh, Eiffel Tower is in Paris and Taj Mahal is in India to be semantically closer. But the semantically closer statement was something else from China, which was not even relevant. Only the relevance was that China word, country's word was mentioned in the statement. Otherwise, it was not similar. So at times it happens that whatever chunks that let's say there are 100 chunks which are similar to your query, but since there is a context window size limitation also in the model, earlier it used to be 4,000 only, then it got increased to 1,28,000. Now I think it is in million, or I'm not sure, but that also used to play important role. So you cannot send all the 100 chunks to the model. So you have to take, let's say, first 10 chunks. And what if the relevant chunk was at the 50th number? So then your data that is generated from LLM will not be accurate or will not be good enough. Let's say in our example, when the Taj Mahal is in India was the third item, let's say it was needed and we were giving only first two items, then we would not have got proper result. So these kind of problems comes, like how you are chunking this. And when you chunk the documents, when you chunk the chapters into statements, first statement is related to second statement, that also information you don't have. So these are the problems that naive RAG used to have. Are you able to understand this? Or if there is any doubt, please let me know. Then only we'll proceed. You're able to get like each and every step. If you just consider the naive RAG, it is good for running demo examples, but it can run into some real-time problems when you try to run it into production. Did everyone hear this? Okay, we'll wait for
Sir,
people.
can you explain once again?
Who is this?
Sham here. Again.
Okay. You were listening and you didn't understand, or you didn't listen at all?
No, I didn't got in between.
You did not get it. Okay. So,
Yeah.
so what I was saying was that is everyone back? Like once everyone is back, I'll repeat again. Senthil is back. I think three, four were back earlier. Sham, Karthik, Satya, four were back. How do we get to know about upcoming session? Kevin and team. Okay, then Kevin is back. Should we start? I think we have 6, 7 are back. The rest all I'm not sure. Ram, should I start?
Yes, sir.
Yes, Aman, please proceed. Yeah.
Okay. So what I was saying was that naive RAG, you understand, no? So naive RAG is you have a vector database where you have already stored your PDFs or your text documents or whatever you want to feed the LLM. And then the second phase is your query is coming and you are embedding that query and then finding the relevant documents from the vector database. And these two contexts, as well as the query, you are sending it to the LLM and it will generate your answer. Okay, so this was naive RAG. But when you were asking about naive RAG, I think Sham, I told you only that there is a pre-processing phase, phase one, phase. So before we can search in the vector store, it should be loaded with data. So when this loading happens, lot of steps are done. Let's say I'm trying to load a PDF into the vector database. So PDF will not go as a whole. So some sentences from PDF, like sentence by sentence or paragraph by paragraph, sentences will go in the vector database. So let's say I have 10 chapters. Each chapter is having 20 paragraphs, and each paragraph is having 4 sentences. Let's say this is the consistent outline of my book. 10 chapters, each chapter having 20 paragraphs, each paragraph having 4 sentences. So there are various techniques how you can chunk this. Chunk in the sense like how will you store the full book? You will store it sentence by sentence. So let's say you take each and every paragraph. So first paragraph you chunk, you embed it, you store in the vector database. Second paragraph you chunk. And let's say, are you understanding the chunking thing?
Yes, sir. I got it.
Okay. So now that you've chunked the documents or chunked the PDF into multiple chunks, let's say the query that comes want a contextual relationship between chunks. So that it can answer it. I will explain using an example later. Or there are various chunking techniques. First one is fixed
Okay.
size. So let's say you divide based on like 20 characters or 20 words. So in that, what will happen? It will like some of the sentences will be left behind in the middle, and some will be so the sentences itself will not be proper. So the chunk that gets created do not hold much meaning. Okay. So there is a lot of research that goes here in the chunking process, how you should chunk your documents or how you should chunk your data so as for it to retain the semantic meaning. Okay. This is one thing. Second, what I was telling, this is one thing. Second, there was this when ChatGPT and Perplexity were being compared. So the one prominent feature of Perplexity that everyone used to say was that ChatGPT can hallucinate, we will never know. But Perplexity, when it will give us sources also, that these are the sources from where I'm getting the data. Are you aware of this?
Yes, sir, I have seen it.
Okay.
This example I have seen.
Okay. So this hallucination was also a problem. So like, let's say if we are giving some answer from this vector database, we will not be able to cite because it would have come from somewhere, but what was the source of that, we don't know. So there are some, so similar to this, there are some limitations in the naive RAG. Second is that let's say there are 100 chunks that are similar to the query. We take the first 10 chunks, but let's say the first 10 chunks were less relevant, but the next 20 chunks were more relevant to the answer. So then what happens? Then the answer that you will generate will be of low quality. Okay. And why don't we take 100 chunks? Why do we take only 10 chunks? So this is because there is a context window for the LLM. It cannot take as much text as you want. Or one more example can be, if any of the example is not clear, you let me know then and there itself. Okay.
So, sir, you mentioned about this contextual threshold, right? We should be able to get only some amount of context to be compared with the test. So, how is this determined? On what basis it is determined?
What is determined chunks?
Yeah, you told right. Like we will have the chunks, and to get the context, we will have to have. We cannot take whole this vector itself, right? Vector DB itself. Only some part we will take. Maybe
Correct.
some threshold. So, like how it is determined, or it is based on the KN and such.
Based
you
on
were showing?
it's based on KNN, it is decided, and like people who design the system, they know like how much is should be relevant, or what embedding model we are using. Maybe our embedding model is having 400 dimensions, or maybe it is having 1,000 dimensions. So when the semantic search happens, it will give me the best possible chunks. So it depends on the system, like system who is designing the system to come up with the answer of K, like what should be my top K. So that is decided by the system designer. But
So that is where this parameters, like this 3 billion parameters, and
sorry,
like we will have the parameters for the models, right? I was saying, like, while downloading the models.
so this top K is like chunks, K chunks.
Okay.
Like, acha, so in the example that I was saying, we took this Taj Mahal and this China.
Yeah.
Okay, so when I said K equal to 2, so I meant take two similar sentences. So top K means what are the similar sentences that should be relevant for generating the answer.
Okay.
Okay, maybe I'll show some examples, then you'll understand. So now what do you see? You see my slide, or you see the same old pic?
Yep, the
They're
PPT.
saying this later.
You see the slide?
Yes.
So there are various techniques. So first is chunking. Chunking means like if you are giving some PDFs, how it will divide into various text chunks and store. Second, to source your answer, like from where the answer is being generated, what was the source of that? So for that, we need metadata. And then re-ranking. Re-ranking means after retrieval, let's say you get 100 similar sentences, uh, and we are taking only first 10, whether those 10 are good enough sentences for the answer or not. And then fusion is like if you have data stored in multiple sources, then when you get the data from multiple sources, how to fuse it, that is the fusion technique. So there are a lot of things that happen. I'll just go to the example, that will be better. Let's leave this for now. So we'll take this chunking example. Okay, so there are various techniques of chunking. So one such technique is fixed sized splitting. Let's that after a fixed amount of characters or tokens, I'll split my text. So this is our text. The quick brown fox jumps over the lazy dog. The sky is blue. And let's say I am splitting over 5 tokens. So the first chunk that will be generated will be the quick brown fox jumps. And the second chunk will be over the lazy dog. If you see, when we use this fixed size chunking, some of the chunks are not relevant. And like if this is the way we are storing, and let's say the query comes, on whom the quick brown fox jumps, we will not be able to answer this, because we only knows that the quick brown fox jumps, but over whom, that is now a separate chunk. We don't know what is the relationship between these two sentences. You're able to get this?
Yep, yep. So
No.
put it in the chat. Yeah, put it in the chat. Yes, yeah.
Okay, I thought you will, maybe it's not clear. Okay, so the way we, okay, 1 minute. So when we use this fixed sized splitting, there can be context breaks. There can be incomplete sentences which are hard to comprehend. And because of this, our search quality will be poor. Okay. Now I'll show one example. So let's say this is our text. Like, let's say this is a text. The Mona Lisa is a famous painting by Leonardo da Vinci. It was painted in the early 16th century and is now housed in the Louvre museum in Paris. The painting is known for its enigmatic smile of its subject, a mysterious woman who has intrigued viewers for centuries. And this is a continuation text, but we have chunked in a format that this goes as chunk one, or let's say as text one, and this goes as text two. Many theories have been proposed about this woman, but the most widely accepted theory is that she is Lisa Gherardini, the wife of a wealthy Florentine merchant. The painting's title, Mona Lisa, is a shortened form of Madonna Lisa, which means Lady Lisa in Italian. So let's say now the user asks who was the subject of Mona Lisa. Okay. So if you see Mona Lisa and subject, they appear in this chunk. Okay. So this will be the most relevant chunk. But here they are not mentioning the subject. The subject they are mentioning is here, Lisa Gherardini. And also there is no link between them that we get the mysterious woman that they are talking about is Lisa Gherardini. Okay. Unless and until there is no link between them, we will not be able to answer. So the best, like if you give this chunk one along with this query, the best your LLM can answer is subject of Mona Lisa was a mysterious woman who has intrigued viewers for centuries. Okay, which is wrong. So here to solve this problem, what they do is they include this overlapping. So what they are doing, this from the painting. So this the painting, one sentence here and the previous sentence here. So now this sentence is common in these two chunks. So now there is a relationship between these. So this is a contextual match, like the continuation of this is this. So with this document overlapping, they are able to solve this loss of context issue. Okay. So like this, there are various chunking techniques. So some techniques is like we chunk after each and every sentence. So how we'll do it? So we can split after every dot, every exclamation, every question mark. Then if we want to break on paragraphs, we can go for 2 line breaks. Okay. And then using, so there are splitters that have come up like in LangChain, you can get multiple splitters which use machine learning models to group sentences and topics semantically close enough, and then they do the chunking. So what I want to say is that the better your chunking technique is, better will be your embeddings and better will be the retrieval. So in real time, if you see when they take this legal documents, they chunk after every article or every section so that all the information that is part of that article is there in that one chunk. In research papers, we have multiple sections like abstract, introduction, methods, conclusion. So they split on those sections section wise. So one downside will be like some chunks will be smaller, some chunks will be bigger, but semantically context will be retained in those chunks. Similarly, for programming, they create the chunks by classes or functions. So if you want to have bigger chunk size, you can have the entire class as a chunk. And if you want to have smaller chunk size, then you can have multiple or individual functions as chunk. And for e-commerce, they chunk by product. And for book and novels, they split it chapter or scene breaks. Okay. So now we'll talk about the metadata. So metadata is like when you chunk the document, you along with that chunk document, you include some extra information so that we know that from where that chunk has come from. And this helps us in citing. So let's say user comes up with a query and you say that chunk 4, 7, and 10 are relevant for this query. And we give these. So when it derives the answer, let's say for deriving the answer, it uses only chunk 10. So if there is some metadata associated with chunk 10, I got, and this answer I got based on this source. Okay. So it helps in retrieval, helps citation. If metadata is missing, then we will not be able to cite the proper source. So we add metadata fields like this. So along with the chunk or chunk text, we'll add like title is doc1, page 3, this is the URL. So metadata is that visible guide that connects user back to original documents. Okay. Oh, I don't have anything. Okay. Uh, is this part clear? Like till here? Okay. So now this agentic RAG, so it is like having the next generation of RAG. So this adds the RAG should be able to ask question on its own. Let's say a query comes, it should be able to give this query to an LLM, generate some text, based on that text, ask some more questions to the LLM, which will help it answer better, which will help it to generate better answers. It can use existing systems like existing APIs, or it can use calculator for math operations. So this kind of autonomy in deciding what further system can I use or what API can I leverage to better my answer. This is what agentic RAG is. So it is like adds autonomy, reasoning, and multi-step retrieval. So a smart agent will not only use this LLM, it will have tools, it will have reasoning also, and it will have multiple systems that it can leverage and form a chain to generate the answer. So that is agentic RAG. I think this is the like this is not enough to explain agentic RAG, but I hope you are getting like if the problem is big enough that it needs multiple systems in parallel, or maybe multiple LLMs chained together, then you can agentic RAG as your solution. Is this part clear? Or it will not be much clear, but all you can think is that agentic RAG goes a step further, and it involves external systems also, and as much help it can takes from existing system it takes, and it is able to do that on its own. For example, let's say if we want to multiply 100 digit numbers, so LLM do not have the capability to do that. So if LLM has luxury of using calculator, then it can do it. RAG will be smart enough to invoke a calculator in the system and give its input, take the output from the calculator and show it. So this is what agentic RAG is. Let's say you want to find, you want to create a bill payment based on the current gold price. So agentic RAG system will be able to call an API, get the gold price right now, and then feed that in the system to calculate the bill. So this kind of adding intelligence by invoking multiple system is agentic RAG. Is this clear?
Yeah.
I'm assuming yes. Okay. So now we'll have a simple quiz based on this advanced RAG. Okay, I should open chat. So everyone ready? The first question is, which technique is used in advanced RAG to break large documents into smaller, manageable pieces? Summarization, chunking, tool calling, scratchpad memory. So most of the people are saying B. Okay. B is the answer. Agentic RAG, what does the system do that naive and advanced RAG do not? Store embeddings, retrieve based on metadata, plan, reason, and make multi-step decision, summarize large documents. Okay. So most of us are saying C. So looks like C is the answer. Next is in Agentic RAG, the system can plan multiple retrieval steps before generating a final answer. True or false? Okay. Next is, what is an example of metadata filtering in advanced RAG? Predict the next word in sentence, retrieve documents only from 2024 tagged finance, generate a new document, compress embeddings into smaller sizes. Most of us are saying B. So B is the answer, yes. And last, which technique is used in advanced RAG to improve the quality of retrieved result? Chunking, scratchpad, memory, multi-hop reasoning, re-ranking. Okay, this is interesting. So I think Satya says D. Is that correct, Satya? D is re-ranking. Karthik says multi-hop reasoning. And then Satya again says A. Oh, chunking. Sendil says re-ranking. Shyam says chunking. Okay. So here we'll try to understand what this question is. So it is saying, first of all, it is not agentic RAG. So there will not be any multi-hop reasoning. Okay. So C can be, you can remove that. So it is saying in the advanced RAG technique to improve the quality of retrieved results after initial retrieval, what can be done? So this is equivalent to like when we were querying where is Eiffel Tower. So it fetched us the first result as Eiffel Tower is in Paris. Second was some China related statement. And the third was Taj Mahal. So if you want to improve the retrieved results quality, you can re-rank your, so let's say you get 100 similar sentences, and which one is better for the query. If you want to know, then you re-rank those sentences and then feed the first kit statements to the LLM. So re-ranking is the right answer here. So I'll quickly cover the key takeaways. So embeddings, we understood that it is converting our text into meaningful semantic. To store embeddings, we need vector database, and vector database forms a kind of backbone for RAG, and it helps us in retrieving the semantically close sentences or data, and that helps us to reduce hallucination and provide knowledge to LLM. And then there are three RAG techniques. One is naive RAG, which is basic retrieval and generation. Then there is advanced RAG, where we try to retrieve smartly with chunking, filtering, and re-ranking. And then there is this agentic RAG, where autonomous reasoning and multi-step planning is done. So with now we can discuss any questions that you have. Now we have all the time.
Sam here. The question is about the last quiz. So the re-ranking we had, right?
Yes, yes.
So this is forcefully done from our end, for training purpose, or this is something that the generative LLM model does it on its own, or what is the case here? Are we forcefully doing this to get the better quality result?
Okay, actually, I did not understand the question, but I can understand re-ranking is not clear. I'll take the question as this. Okay.
No, actually, my question is that initially we are doing the chunking, right?
Initially, you're doing the chunking. That is correct.
Yeah. So after that chunking, so we are getting, say, for example, some three lines for our query. So three matching on the basis of the contextual match, we are getting three answers. So you are like the answer is re-ranking, right, for this after the initial retrieval. So I came to the part of this initial retrieval, so where we got three similar answers. So you want us to the answer is re-ranking. So this re-ranking is done uh, on the architectural level, or like we have to forcefully do it, or something.
It has to be done on the architectural level. So I'll tell
Okay.
maybe I did not explain it correctly. So see, this is your vector space, okay? And this is your query. Now let's say your query is same, like where is Eiffel Tower, okay?
Okay.
And let's say this Eiffel Tower is in Paris. And let's say this is something in China, but not relevant. And let's say this is Taj Mahal. Taj Mahal is in Delhi. Okay.
Okay.
So when we said that we first K documents, it took this. And
Okay.
when we said we want first three, it took this. Okay.
Okay.
This is clear, na?
Yes, sir. This is clear.
So now what I said was that according to us, logically, when we see through our naked eyes, these should have come as first two because they are more semantically closer. But it's not coming.
Yes.
Okay. So likewise, let's say you come up with a query and let's say your K is 100, let's say.
Okay.
Okay. So it will come up with that vector space, big space. So let's say, and every chunk here is a big paragraph, let's say. So you have 100 paragraphs that can supply the answer to a query.
Okay.
Now, the way RAG works is we take our query and we take this contextual data, we fuse this and send it to LLM. But LLM has context windows, and the amount of tokens that you're sending to the LLM is directly proportional to the cost. Okay.
Okay.
That's the reason we do not send that whole bunch.
Okay.
So that's why we say that we'll send top K, top 10, top 5, top 6. But the problem is the top 2 is not the relevant information. The first information is this, the second relevant information is the third information. So our similarity search is not whatever sentences it is giving us, it is not ranked in like what sentence is more appropriate for our query. So that's why it says if you want to improve the quality of your retrieved results, you first take the initial chunks and let's say you get 100 chunks, but you want to send only 10 chunks to your LLM along with the query.
Okay.
Then you re-rank them, and re-ranking can be another system. So that will be one more layer that you will have to introduce as a system designer.
And it is not included in that picture you were showing, right? So
it was not included. So that's why I was saying like GenAI RAG is a little bad system to be deployed. It will not give you the
okay.
That's why you have to improve some portions of the GenAI RAG or include some additional layers to it of your system.
Okay.
This is one aspect. So you understood like why re-ranking is required? You understood this?
Yeah. I understood it, but the thing is, like I understood it like it is a separate layer. We have to have it so that while before sending it to the LLM, like we can have a better result. Yeah,
Right.
that part I understood. But still, what I'm thinking is like how this re-ranking works itself is like again it will be an LLM, right? How it should know on what basis it is.
I think that you should search how re-ranking is applicable in
Okay.
how people are
Okay, sir.
attempting it. So there are various types of re-ranking, but I will tell you one more aspect here, okay, which I think I forgot. So let's say you understand now that there is a limit to the context window, okay?
Yeah.
And you are coming up with a query, and that query is finding 100 paragraphs. Let's say 100 paragraphs, okay?
Okay.
And let's say all 100 paragraphs are needed.
Okay.
Like as a system, I'm deciding, like, based on the system that for which I have written this LLM. Let's say if my system is saying that this chunk is relevant, there is no re-ranking. It's not like first, second, third. All the chunks I need to derive my result. Let's say
Okay.
all these 100 are paragraphs. Let's say
Okay.
sending 100 paragraphs is again a tedious job. So now what people do is, when they get these 100 chunks, they will have one LLM here. And
Okay.
they will convert these 100 paragraphs into the most relevant. They will pass the query and they will keep passing these paragraphs. And LLM will
Okay.
shortened version, not the like 40 lines, 40 sentences, compress that into some meaningful sentence. And then take two sentences from each paragraph, then it will send 200 sentences. So that this also is used in
Okay.
some of the systems where you
Okay. Okay.
have this limitation of context windows. So they will take these answers or the similar chunks, they will feed it to LLM and say that reduce the size or just give me the relevant thing from this, what I need. And then it will reduce that, and that you give it to your final LLM. So this is also one of the techniques. And how
Okay, sir.
it is
Understood.
done, I think you should search once, because
Yeah,
there
yeah, that I will do. Yeah,
people are using different techniques.
understood, understood.
Okay.
So, like, there is no difference. Like, this always comes under advanced RAG only. Since we are using this LLM in between, does it make it agentic LLM, agentic RAG or something, or will it in the category of advanced RAG only?
No, there is no category as such. Like, people design racks.
Okay.
People don't design agentic RAG. Okay. Let's say you are running a RAG and simply you include calculator for mathematical operations. You will not go to LinkedIn and start claiming that now I'm using agentic RAG. It will still remain RAG. It's just a difference.
Okay. Okay.
Or theory wise differentiation is done.
Okay. Okay, sir. Understood. Understood.
Nobody
Yeah.
asks that you are doing advanced RAG or agentic RAG, as long as you are doing what
Maybe.
is supposed to be done.
Yeah. 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 Understood, sir.
Any other question?
No. Yeah, that answered it. Thank you.
Okay. So anyone else, if something is not clear, you can ask. Or let me see how many are still there, or people are all gone.
Yep. So we almost had around
20?
yes. So always 20, 21, 22, and the last 1 hour we had around 18.
Okay, okay.
I think the count is fine, but I think this is one of the best session we have ever had as part of the video enablement session. Someone, thank you so much for being a great trainer. I have never seen such an interactive audience.
So
Yeah.
how we started with embeddings, I thought like we have taken up a very odd topic, because it's little hard to explain. Like board, if you have the board now, it's very easy to draw things and show a vector these things, but over this it is little hard. So if
Yeah.
I'm able to add like some meaning to the people who attended, I think that should serve my purpose, I think.
Sure, but yeah, it's definitely very much clear, because I was not aware of some of these concepts and I was able to quickly grasp, and you were very well clearly articulating each of those and connecting the dots and giving the relevant examples. So these were adding much more value to the session as well.
Okay.
So Aman, In the meantime, I would like some of the audience to share about themselves and their feedback, because we had a very smaller team today.
Okay, okay,
I think they were very interactive.
okay.
So I would like them to talk about the session and maybe their background, where they come from, and what is the intention behind attending this meeting, etc. Maybe for a minute from each of them. So definitely, I see great participation to the interaction.
Uh, Thanks, Rambam, for pulling me into this session. This is Sriram. Hi, Aman. So just a few days I have been part of exploring these RAG techniques, because I have some professional assignment on these topics, and your session is awesome on the topics that you have explained, mainly on the re-ranking concepts that I'm exactly looking of how to improve the retrieval aspects, and it's very great and in touch on your things. And thanks, Ram, for having this session. Thank you.
No problem, Kiran. So can you explain more about your background, like where are you from and what is your role, current role, and how it's going to help your profession, etc.
Yeah. So basically, myself, I'm a part of Infi. I'm working under a kind of a strategic technology group as a senior technologist. So that's a kind of a background. It's more or less on the research side, and we will be working with many of the customers in GenAI solution. Mainly, I came from most of serverless and full stack and data engineering background, and this generative AI is pretty much new for me. I'm just in terms of upskilling for past 3 to 4 months on this generative AI techniques, and this is all about myself, Aman and Ram.
So he's your senior, Ram?
Yes.
Yeah, I'm his senior.
Awesome. Thank you, Siram. Who wants to go next?
Sham here, actually. Yeah, I joined the session a little bit late. After seeing your LinkedIn post, I joined here. So I wasn't aware of this happening, actually. So maybe I will introduce myself first. So I'm working as a senior software engineer in Bosch. Last week, I attended a event in the Global AI bootcamp in Presidio. So that's where I came to know about you, and your post actually helped me. And this is where this is the part actually I'm learning about this AIs, and yeah, I have also enrolled in Scalar, so I'm just exploring this AI field, and yeah, this particularly about this RAG session. I mean, very thank you for letting me know about this RAG. Actually, yeah, this is my first session about the RAG itself, so I got a pretty good idea on this. Yeah, I will also research further about this. Yeah, thank you, Aman and Ram.
Thank you for joining. And
Thanks, Sham.
Yeah, thank you.
Thank you, Aman. It was really a wonderful session today. Actually, I was learning RAG these days. I was going through some blogs and things and learning. But today's session was like a refreshing session, what I have learned till now. And the concepts was okay for me before, but now I'm quite pretty much clear with the concepts with the re-ranking, chunking, and everything was really clear to me. Thank you very much.
Kavya, do you want to introduce yourself on what you do and what is your intention behind attending this session, etc.?
Yeah. So this is Kavin. I work for
Sorry,
Caterpillar.
Kavin, I was asking Kavya to finish up.
Okay.
Is it Kavin or Kavya? Kavya, right?
Yeah,
I thought you
Kavya.
asked.
Yeah, Kavya, please go ahead. Yeah. So Kavin, we will come to next.
Yeah.
Currently, like, I'm a full stack developer working as a freelancer, but my interest was I wanted to learn AI and what things are happening, because everywhere it's AI. So what is going on? I wanted to know. So because of that, I thought of learning RAG and getting to know what is really a RAG and what happens with the chatbots and ChatGPT things. So I was learning those things, and today's session was actually introduced to me by Mr. Ram sir. So I thought of attending, and it was really a nice time I had today with you. Aman.
Thanks.
You can go for it, Kavin. Yeah.
Yeah, so this is Kevin. So I'm part of Caterpillar. So I predominantly work on cloud technologies and mostly with serverless components, right? And I started learning about this AI, and then as part of my upskilling program, and then they wanted it in my organization as well. So last week I started, I think a couple of weeks back I started with Udemy. So that is going on, but I think this one is really good because we had been simultaneously using that in Snowflake as well, right? With few learning models. We mostly use Snowflake and AWS. So we have been doing some experiment with Snowflake, and now I have a clear explanation of what is my colleague doing, and so that I can contribute more to it. So this is actually a great session for me. Thank you, Aman and Ram, for having this setup.
Thanks for joining.
Yeah.
Great. Thank you. So who wants to go next? So we have got three more.
Hi, Aman. Today it's a grateful session for me because I'm a new to AI, like a generative AI and also agentic AI. So basically, I am a full stack developer in a startup company. So it's really good for me, and also today I learned more insights from this session. Thank you for this, and thank you for arranging this session, Ram.
No problem. Thank you, Sadhya. Thank you so much.
Yeah, thanks.
Okay, so you've got Senthil. Yeah, Senthil, do you want to go next?
Yeah, yes, Ram. Thank you, Ram, for coordinating this kind of sessions, and thank you, Aman, for the wonderful session today with with RAG. Actually, I'm working at Boss Global Software Technologies. In my project, there is a lot of initiatives going on to incorporate GenAI techniques, and so I'm working on that. So this will be very useful session for me.
Awesome.
Thank you, Aman. Thank you, Raman team.
Thanks, Senthil, for joining.
I think we've covered almost everyone except Karthik. Okay, so Karthik. Oh, no problem. That's fine, Karthik. So Selva.
Ram, hey, Aman, thank you for this session. I think most of the sessions I have attended in other places. It's not like comparing, but mostly people will teach about how to generate embeddings. Like they will teach how to use it, but the way you explain today is how it's working. So people get that understanding, which is really the fundamental or basement of the RAG. So that insight won't be available easily, but thank you so much for sharing that perspective of like how the people say, like you convert into vector, then it will based on the vector similarity, it will search and it will send it to LLM. So that's what most of the people we know, like what is RAG, but how that vector is done, how it's assigning the weightage, and how it's assigning the mapping the similarity in the vector structure. So that insight is really a wonderful thing. I wanted to rewatch it again, so that's how I'm thinking, because this is something core which everyone need to understand. So thank you so much for sharing your insight and the time you put together on this for the people. So thank you so much appreciated.
Thanks, Selva.
So for me, definitely when I was actually going through multiple materials online, and I was also part of another sessions. but I'm not sure how you have actually put together this flow of explaining RAG and such a complex topic, and for the wide variety of audience who had almost I would say 0 to 10% of knowledge, and everyone is able to grasp what we were actually intended to deliver. So I think this is one of the best skill I have ever seen from you past 10 years. I think this was very effective to this group, and also it's going to be on demand for anyone who is looking for in the future. So thank you so much for your valuable time in putting together and preparing in such a nice way out of all your busy schedule with your new development and new research, etc., etc. And I know Sunday 10 a.m. is not your morning, but still thank you so much for making it at 9:50 and being available in the office. So
Thanks, Ram, for the opportunity. I think I'm the only one remaining to appreciate the session. So I think it is months back when we decided that we'll have this session, and generally sessions we have of 1 hour. So the first 5-10 minutes goes waiting for the participants, and then within the next 40 minutes you have to rush, and the last 5 minutes are remaining for questions. So when Ram told me that it's going to be 150-minute session, that's when I was like, oh my God, will we cover? So then I started looking into things that can actually add meaning to it. And I think all the magic was done by the IPL match yesterday, CSK versus DC. The only downside is that CSK lost, but I think we'll have CSK up the table very soon. So thanks, Ram, for inviting me for this session. And yeah, it was a very nice experience. I think very nice Sunday morning spent. So I think now I can enjoy in the evening.
thank you so much. Thank you so much.
Thanks, Ram.
Sure. Looking forward to collaborate more in the upcoming days, Aman. Definitely your expertise and your contribution to the community is much appreciated. And
Sure. Okay.
Thank you so much, everyone. So I have shared the feedback form. I would like all of you to fill in if you haven't, and I'll post the WhatsApp group too. Thanks so much, everyone. Happy Sunday.